Hi everyone, my name is Abhiraj Garikapati. Welcome to my YouTube channel Amazing Abhi. IML stands for Initial Machine Load. The easiest way to understand it is to imagine a large building opening for the day. Before anyone enters, the lights must come on, the access system must load the rules, the elevators must know which floors are active, and the security system must know who is allowed where. IML is that kind of startup moment for a large Z system. It is the moment the machine wakes up, reads the IO/CDS, builds the logical IO world, and gets ready for operating systems to start later through IPL. IML is often compared to power on reset, but it is more than simply turning power on. Think about restarting a very large transportation control center. The center does not just switch on screens. It must load the route plan, check the control systems, and prepare the environment before traffic begins. During IML, the machine reads the selected IO/CDS and uses it to create the structures needed for IO. Only after this machine-level startup completes can an operating system be loaded through IPL. A common beginner mistake is mixing up IML and IPL. A simple story helps. IML prepares the building. IPL lets a resident move into an apartment. During IML, the machine itself is being initialized and the IO world is being built. During IPL, a specific operating system is loaded after that environment is ready. If IML does not complete successfully, there is no stable machine environment for IPL to use. So IML is the foundation, and IPL comes after it. The IO/CDS is like a detailed city map before IML. It describes roads, allowed routes, and destinations, but it is still just a map. During IML, that map is read and turned into active machine state. This is like a traffic control center loading the day plan before allowing vehicles onto the roads. After IML, the definitions are no longer just text. They control which partitions, paths, control units, and devices the machine understands. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing Abhi grow naturally. IML is not something a random operating system starts by itself. It is normally triggered through management tools such as the support element or the hardware management console. Think of this like a facility manager opening a major building from the control room. The manager decides which approved startup plan should be used. In the same way, the operator selects the IO/CDS that will be loaded. That choice matters because the selected IO/CDS becomes the active IO map for the whole machine. The IML journey can be told as a simple startup story. First, an operator starts IML from the management environment. The hardware performs startup diagnostics. Then the selected IO/CDS is loaded. IOCP validates that the configuration follows the rules. If validation succeeds, the channel subsystem firmware builds the IO structures described by the configuration. After that, the machine is ready for IPL, which means operating systems can finally be loaded. The important idea is that IML prepares the stage before any operating system begins its performance. IOCP is the validation gate. Imagine submitting a building plan before construction starts. If the plan has missing rooms, wrong references, or unsafe structure, the inspector rejects it before anyone starts building. During IML, IOCP checks the IO/CDS in a similar way. It looks for formatting problems, invalid definitions, and relationships that do not make sense. If IOCP finds a serious problem, IML stops. That may feel strict, but it is much safer than starting the machine with a broken IO map. During IML, the machine builds more than a simple list. It creates the active hardware structures that will be used by operating systems later. Think of a theater before a show. The seating plan is one thing, but before the audience enters, the seats, lights, doors, and stage areas must actually be ready. In the same way, IML prepares channel subsystem structures, channel path definitions, physical port relationships, control unit definitions, and device address ranges. These become the IO world that the operating systems will later live inside. Before we move ahead, please take a second to share on this video. Sharing helps this video reach friends who may also enjoy anime, gaming, travel, cricket, chess, career basics, or personal stories. Your support helps Amazing Abhi grow naturally. A system can have multiple AOCDS files stored, but IML activates one selected AOCDS. A simple comparison is a train station with several possible timetables saved in the office. Only one timetable can be active for today. If the staff select the weekday timetable, the station runs by that plan. If they select the holiday timetable, the station runs differently. During IML, the selected AOCDS becomes the active AO map. The others may still exist, but they are not controlling the machine at that moment. The machine needs a valid AOCDS because it must know the I/O world before operating systems begin using it. Imagine a delivery company starting the day with a damaged route map. Some streets are missing, some addresses are invalid, and some routes point to places that do not exist. It would be safer to stop the trucks before they leave rather than let them drive into confusion. IML works with the same safety mindset. If the AOCDS cannot be assembled and validated, IML fails instead of building an unsafe or incomplete I/O environment. IML affects the whole machine. This is very important. It is not like restarting one application or one partition. A full IML resets the machine-level environment. Running operating systems are stopped. I/O activity stops, and the new AOCDS takes effect across the entire machine. The building analogy is useful again. If one apartment has a problem, you might restart something inside that apartment, but IML is more like shutting down the entire building infrastructure and starting it again. That is why production environments treat IML with serious planning and caution. One surprising lesson is that a small I/O configuration change can have a large operational impact. Imagine a city needing one new road connection, but adding that road requires restarting the entire traffic control system. That is not something the city would do casually during rush hour. In the same way, certain machine-level I/O changes can require IML if they cannot be applied dynamically. Since IML affects a whole machine, teams plan and test I/O configuration changes carefully before using them in important environments. This topic also helps explain why dynamic I/O is valuable. If every configuration adjustment required a full IML, then even a small change could interrupt many workloads. Dynamic I/O reduces that need by allowing certain changes to be applied while the system continues running. A simple comparison is road maintenance at night using temporary lane controls instead of closing the whole city. The key point is not to memorize dynamic I/O details yet. The key point is to understand why avoiding a full IML can be so valuable in large production environments. Before we move ahead, please take a second to like on this video. A like tells me that you enjoyed this topic. Your support helps Amazing API grow naturally. When IML fails because the AOCDS is invalid, it can feel like the machine is being difficult. But the failure point is early by design. Imagine airport security finding a problem before passengers board the plane. That delay is inconvenient, but it is safer than discovering the problem in the air. In the same way, if AOCP finds an assembly error during IML, the process stops before operating systems begin using a broken I/O map. Early rejection protects the larger environment from unsafe startup. For beginners, the building story is one of the easiest ways to remember the relationship. IML opens and prepares the building. The AOCDS is the access and route plan that tells the building which floors, doors, and paths exist. IPL is when a specific operating system enters and begins running inside its assigned space. If the building has not been prepared, the resident cannot safely move in. This mental model keeps the order clear. First IML, then IPL. First the machine environment, then the operating system. The key takeaway is that IML is the gate through which the machine-level I/O configuration becomes real. The selected AOCDS is loaded, IOCP validates it, and the firmware builds the active I/O structures that operating systems will depend on. If the configuration is invalid, IML stops before the machine starts workloads. If IML succeeds, the machine is ready for IPL. In the next topic, the focus shifts from preparing the machine to loading an operating system into that prepared environment. This topic ends with a simple idea. IML is the moment the written I/O plan becomes the active hardware environment. Before IML, the AOCDS is a configuration map. During IML, that map is checked and loaded. After IML, the machine has the structures needed for operating systems to start. The next topic continues the story by looking at IPL, which is the step where an operating system is loaded after the machine itself is ready. If you enjoyed this video, Please hit the like button and subscribe to Amazing Apai. Subscribing makes sure you do not miss the next video, and it gives me motivation to keep improving the quality of every upload. Thank you for being here, and I will see you in the next one.